Hi, today we're going through the PAT paper from 2012 and looking at question 17, the last multiple choice question. Now question 17 is the last multiple choice question. I've decided to do it in a separate video, so I think it requires a bit more thought than the other multiple choice questions. So what happens is we're given a slider on a frictionless ramp. And we're told it slides down this ramp and comes into contact with this circular loop, which is also frictionless. And we're asked about its behaviour as it goes down the slider and up. Does it reach the top? Does it reach the top and fall straight down? Does it come off the ramp? What happens to it? Now, when I first saw this question, the intuitive answer to me was that, well, it's got some potential energy here. It's at a height h here. So it has some potential energy, mgh. And, well, this is at the same point. So you'd think, well, it's going to change all its potential energy, kinetic energy, come up, and then stop dead when it's changed all its kinetic energy back into potential energy. And it would fall straight off. But what actually happens is not this. So what we've got to think about is when the mass is like at some arbitrary point here, okay? It's moving with velocity vector, let's say tangentially to the circle, okay? And what force is acting on it? Well, you've got the centripetal force, clearly, and you have its weight downwards. So, as we know, velocity has two components. We think about it in a vertical and a horizontal direction. And we know from Newton's laws that a mass will not change velocity unless acted upon by a force. So when the mass has slid down here, it comes to the bottom, and it's going to have velocity in this direction here. It's going to have horizontal velocity. And as it moves up, it's going to have a vertical component of velocity and a force of mg downwards that's going to be acting to slow it down in the vertical direction. However, what we notice is there's in fact no force acting on the object to slow down its horizontal velocity. So although its vertical velocity may stop, because this force will act enough to stop it in the vertical direction, so there'll be a point where it reaches the maximum vertical height, it will never actually stop accelerating, so not accelerating, stop moving horizontally. So there's no force to actually stop the horizontal components. What's actually going to happen? It's going to come up here, it's going to change at some point below t. At some point here, it's going to have a kinetic energy, and it's going to reach its maximum potential energy. It's never going to get to the top with zero kinetic energy. It's always going to have a horizontal component of velocity. So in fact, it's going to come along like this, detach itself, and come down like this. Now we can derive this algebraically and prove that this is the case. In fact, the angle, if we were to define an angle here, theta, this is the center, if imagine the center of the circle in theta must be less than sine minus 1 of 2/3. So we see theta can never be the pi by 2 that it requires to reach the top. But we're not going to go through it because this is a multiple choice question and it's not worth it. You need to be fast. So the answer is it's going to never reach the top t.